Hey everyone, this is Isaac from Okiko. So today I'm going to take you through linear law. If you've seen the previous video on this, you'll know that we went through the non-graph questions. And today we're going through the questions where you specifically have a graph either already drawn out for you, or in this case, you'll have to draw it yourself. So before watching this video and trying to learn this, I highly recommend going to see the previous video if you haven't already. And if you're one of my students who's watching this, also do complete the worksheet in full and try to really master it. So I'll just walk you through a couple of graph questions today and show you how to answer them with full marks. Let's take a look at the first one. An experiment was carried out and values of y for certain values of x were recorded. The table shows the values recorded. However way they phrase this, they're always going to give you a table with x and y. And maybe they will say a line after that looks like this. So the relationship between y and x is going to be modeled by this equation where a and k are constants. For question A, which says draw a straight line graph for ln y against x, we're not really going to care about this equation yet. You don't need to worry about it. At the moment, we need to just see how to draw our straight line graph. And keep in mind, in linear law, we are not using the setup of the y and x-axis like we do in 95% of all the other chapters. In linear law alone, this is the only chapter in the syllabus where your y and x-axis will change to become something else. It could be LGY plotted against the root of x. It could be, ln y against x squared. Literally could be anything, but just the regular vanilla y and x-axis. So in this case, if we want to draw a straight line graph for ln y against x, we have to make sure our table of values also goes as ln y against x. So right now we have the x values, no problem. But you'll notice we don't have ln y values. So what you should do is just make another column like this, and you can use your ruler as you're writing this out on the physical exam. You can just make another table like that, and you're going to use your calculator to get all the possible values of ln y. So in this case, if y is 10, ln y would be ln 10, and that gives me around 2.3. If y is 13, ln y is ln 13, that gives me 2.6 or 2.56. And slowly but surely, you can kind of get the gist here. What I would recommend putting down at first is probably up to 2 decimal places. So I'll probably say this is 2.30, and the next one actually is 2.56. And you're going to do this for the rest of the table. So ln 22 would be 3.09, ln 35 would be 3.55 or 3.56 really, ln 50 would be 3.91. So now we have a table of values that we can use to actually draw the straight line graph. When you try to draw the straight line graph, all you need to do is take coordinates, but you have to be careful here to take the x coordinate and the ln y coordinate. We're no longer using this row of y coordinates because the setup that we have, if you look at this grid here, is ln y being plotted against x. So you have to make sure that your coordinates are also plotted as ln y against x. So just as an example here, I'll take the first column. You have x as 15 and ln y as 2.3. So that pair of coordinates would be 15, 2.3, and that's what I have to try and plot down. So if I maybe go down to the graph here, you'll see 15 is right here, and I'll try doing this in a bit of color so it's a bit easier to see. 15, and then 2.3 is going to go up to roughly, okay, so 2 is around here and 3 is here, so 2.3 should roughly be 1, 2, 3. That's going to be 2.3. So I'm going to mark that spot with an X mark. And that is going to be 15, 2.3. Alright, so just keep that in mind. We are plotting with x and ln y for this question, not just x and y. You're going to just repeat this for the other coordinates that you see along the way. So I'm just going to do one more example here. And you can really watch this for as long as you need to, but you can speed up the video if it gets a bit boring. So x is 30 and ln y is 2.56. I'm just going to plot that here. 30 and then 2.5 is going to go all the way up. Let me see. This is 2.1, 2, 3, 4, 5. That's 2.5. So 2.56 should be roughly in the middle of 2.5 and 2.6 itself. So I'm going to put it in the middle of those two boxes. That's the second point. And like I mentioned, you're just going to do this for all the other points. Just make sure you're taking the ln y coordinates. So 45, 3.09, that's another pair of coordinates. I'm just going to take them here. Okay, 45 is all the way down here. I'm just going to draw this blue line going up to maybe 3. 3.09 is really close to 3.1, so I'm going to mark the point at 3.1 itself. And that's going to look something like that. And then let's see what else we have here. We have 63.56. Just going to go a bit faster at this point because we are just plotting down these coordinates. So here's 60, 3.1, 2, 3, 4, 5, and it's 3.56. So that's going to be in between, kind of like 3.55. And that's going to be in between 3.5 and 3.6 itself. I'm going to get rid of all the other annotations. And the last point is 75, 3.91. Okay, so 75 is down here. Just going to draw a line going all the way up to 3.91. So that's right below this 4 here. Here's 4.0, here's 3.9. 3.91 should roughly be around there anyways. So we're just going to plot that. And once you have that, you want to take your ruler and you're just going to draw a straight line going through all of these points. Alright, so when you have one point that doesn't really fit here, that's okay because you can draw a line of best fit. Now, the line doesn't necessarily have to pass through all the points, it just has to pass through most of them and be close enough to the others. So you can draw the straight line as I've drawn here, just connecting all 4 of these points. And then this one is a bit of a slight outlier, but that's okay. You can also extend this line going back all the way to the y-axis, and this is what most people are going to do for this question. This is very useful because in the next question you will have things like this. You will have to find the equation of the line, and extending it all the way back allows you to find the y-intercept. So one recommendation is that you draw your line like this. As long as you have a straight line of best fit passing through these points, then you should be good to go. And I'm going to show you the answer here. You have points plotted here. As you can see in the mark scheme, they have mentioned specifically you need to have x and you need to have ln y. So these are the values that we had as well. And you also need to have a single ruler straight line of best fit. So you need to use your ruler for this. Try not to eyeball it. Just use your ruler and then shoop, go like that. That would be the answer for question part A. Now, moving on to question part B. Find the equation of the line in part A and hence find the values of A and K. We're going to find the equation of the line in part A first, and this is very similar to what we have done in the non-graph questions. So in this case, this is a straight line, which usually follows the format of y equals mx plus c. Now, we're not going to use y equals mx plus c because we're no longer using the y and x axis. Instead, we're using the ln y axis, and we're actually still using the x axis, so that's fine. Alright, make sure that your y equals mx plus c formula changes to reflect what kind of titles you have here on this straight line graph. So in this case, we're using ln y against x. That's why I've made my straight line equation like so. We're going to find the values of m and find the values of c. So step 1 is to find m. And the m formula is going to be the same as the gradient. Now, you used to know this as y2 minus y1 over x2 minus x1. Keep in mind, we're not using y2 minus y1 anymore. We are using the two ln y values. So this is really important. You should not use the y values that you have in your table, but rather the ln y values. And so what you can do is you can go back all the way up here, and you can take two ln y values and then two ln y values and then two x values from two different coordinates. So in this case, I'll just take the two that are furthest apart. I'll take 2.3 and 3.91 and I'll subtract that together. And then I'll divide that by 15 and 75 minus together. So let me go ahead and show that. So in this case, I'll do 3.91 minus, I think the number was 2.3 if I'm not mistaken. Yeah, 2.3. 2.3 over 75 minus 15. And if we go up here, I'm just going to put that into my calculator. And that gives me 161 over 6,000. Alright, so that's our value of m. Once you get the value of m, go ahead and find the value of c. You're going to update the value of m in your equation. So that's ln y equals to 161 over 6,000 x plus c. And you really want to just take a point and then substitute one pair of coordinates into it. So the easiest coordinate that we're going to use is the one with the smallest numbers. That's going to be 15. And then this 2.3 here. So make sure when you do this, when you sub in whatever coordinates you're using, you are only using x and ln y values. Remember, for this whole question, we shouldn't even consider using any of the numbers in this table at all, because the straight line graph has been set up because we have ln y plotted against x. A straight line graph wouldn't even be possible if we just use regular y values. So that's why we have to take one of the coordinates using x and ln y specifically. I'm going to take this coordinate here, 15, 2.3, because that's the easiest one. So I'm going to say sub in 15, 2.3. And when you do this, the whole ln y gets replaced with 2.3, because remember, 2.3 doesn't represent y, it represents ln. It represents ln y. And then your value for x is 15. And we are going to calculate this out. So let me just times 15. 161 over 6,000 times 15. That's 161 over 400. And c is 2.3 minus that, which if I put into my calculator gives me 759 over 400. So that's the value of c and the value of m. You're going to take this value of c one more time and then just put it into the next part here. So update your equation with the values of m and c. That's 161 over 6,000 x plus 759 over 400. That is the equation of the line. And this is actually part of the answer. We want to find the values of a and k given that we have this equation. And we have to give each value correct to one significant figure. So here's what we need to do. This a and k is actually located in this equation here. Y equals to a times e power kx. Now that's the equation if y was made the subject. So what we need to do is we need to use the equation we have now and try to make y the subject so that we can compare it to the format that the question has. Because right now we have ln y as the subject. So what I'll do is I'll just shift this ln over to the right hand side. Keep in mind that ln is log base e. So when I move it over, it should become exponential base e. And everything that is on the right hand side gets pushed up as a power like so. And this is an indices style of equation where if you notice here, y equals ae power kx is the number a multiplied by this e power kx. Right now, we just have one number in here with a bunch of powers. So we're going to try and split up those two powers so that they become two separate numbers that are multiplying. This would be like the reverse of your laws of indices. And I'll write it out here. It's actually e power 161 over 6,000x multiplied by e power 759 over 400. Because this is how you would join them together and add their powers. They would have to be two separate numbers multiplying like this. I'm also going to do a bit of rearrangement by putting the e power 759 over 400 at the front, and then multiplying this by e power 161 over 6000x at the back. So that way, when you compare the equation that we have right now to the format of the question, it's pretty clear to see that we have y and y match up. And if you see the highlight in blue, the e power 759 over 400 is the same as this capital A, which multiplies by this e down here, which is raised to the power of kx. So I'm just going to highlight all those little pieces there for you to see that they are all a one-to-one comparison. The y is the same, the e is the same, the power of x is the same. It's those numbers for a and k that we're interested in blue and yellow. So if you wanted to find the values of a and k, you would just need to say a is equal to e power 759 over 400. Let me just write this a bit nicer. And the question has mentioned for us to put that in the form of one significant figure. So just say this is e, or rather I've just put it into my calculator. This is 6.669. And you can round this to a 6. This is, okay, one significant figure is actually just the ones place here. So that's going to be a 7 actually. And then if we look at the value for k in yellow, the value of k is actually 161 over 6000. And if we put that into a calculator, that's going to be 0.02683. And to one significant figure, that's 0.03. You would actually round this 2 up. And that would be the correct answer. So all in all, a is 7, k is 0.03, and the equation of the straight line looks like this. Let's go ahead and check the answer and see if that's correct. So if I go to 8b here, we have ln y equals 0.03x plus 1.8. That's essentially the same as what we have. We've just put it in fraction form. And then you can see a is equal to 6 or a is equal to 7. And then k is equal to 0.03 or k is equal to 0.02. You must have found this using the linear points or the linear equation. So you either use your graph over here, or you use the points on that graph itself, which is what we did. We found the value of m using that formula, and then we found the value of c by subbing in one of those points. So this is perfectly fine. And that's how you get the 5 marks over here. I'll give you a while to take a look at it. Let's go to question C. Find the value of x for which y is equal to 17. Now, if I want to do this, this is like a bonus question, because all you would have to do is sub in y equals 17 into one of your completed formulas. And really, you can use this one that you have here. So ln y is equal to 161 over 6000x plus 759 over 400. I'm just going to write that down here. So 161 over 6000x plus 759 over 400. When I substitute in y as 17, that will look something like this. Remember, we are only subbing in y, so this becomes ln 17. And this is now an equation where we would just have to solve for x. So let's go ahead and isolate x by first moving 759 over 400 over. That would become a minus 759 over 400. And to isolate x, I would have to divide by 161 over 6000. If you divide by the fraction 161 over 6000, it's the same as timesing by the fraction flipped upside down. 6000 over 161. So x is equal to 6000 over 161 multiplied by everything you see on the left hand side. And this is something you could type into your calculator to get the final answer for. So let's try it out. multiplied by ln 17 minus 759 over 400, and we get 34.87. They haven't specified what way to leave our answer in, so I'm just going to round it to the IGCSE default, which is 3 significant figures. That's going to be 34.9. Let's go ahead and check our answers to see if we got it right. So here was part B. And for part C, you'll get it right as long as you have a value of x in the range of 33 to 37.5. This range is to account for people who draw their graph slightly off, because everyone has a different pencil thickness and may get slightly different values from their graphs. So our answer is 34.9, which is in between this range, so we should have no problem here. That's how you do these type of graph questions. Question B and question C is very similar to the non-graph questions. You just have the additional task of actually drawing out that linear log graph by yourself. So go ahead and take a look at question C. I'll leave the work in here. And if you want, you can just rewind the video and go back to any previous parts. But we'll look at another example after this. Okay, now let's take a look at this next question. So the table shows the variables x and y, which are related by the equation y equals ab power x squared, where a and b are constants. As you can see, the table there shows, once again, we have values for just x and y. And the graph that we're trying to draw is a straight line graph of ln y against x squared. So the first thing you want to do here is ditch the x and y values and create a table of your own. Specifically, a table we are going to need for not just ln y this time, but we're going to need x squared and ln y. So you're going to need to take all the values here for x and then square them. And then you're going to need to take all the values for y and then take ln of that. So I'll give you a few examples. If I take x equals 1 and I square that, that's going to be 1 squared, which is 1. If I do 1.5 and then I square that, that is going to be 2.25. If x is 2, then 2 squared should be 4. If x is 2.5, 2.5 squared should be, let's see, 6.25. And if 3 is squared, that should give me 9. Now moving on to ln y. ln of 14 gives me 2.63, or well, 2.64. ln of 33.3 is 3.51. And let's see here. ln of 112 gives me 4.72. I'm just rounding these to 2 decimal places. ln 532.8. That's 6.28. And of course, the last one, ln 3584, 8.18. So these are the points that you're going to use in order to draw the graph. So we're going to do it the same as the last question. Feel free to speed up this section of the video, but if you want to see how it's done, feel free to watch ahead. So I'm going to take 1 and 2.64. Because remember, we are using coordinates specifically about x squared and ln y. So I'll take the first one, which is 1, 2.64. So let me go down here to 1. And I'm just going to do this in blue like the last one. So 2.64, okay, 2.1, 2, 3, 4, 5, 6. And I'll just mark one at 2.6 around there. That should be good. Let's go for the next one. 2.25 for x squared, 3.51. Okay, 2.25. So if the scale here is from 2 to 3, and there's 4 gaps in between, then each gap should be worth roughly 0.2. So 2.25 is like 2.3 if you round it up. But really it's in the middle of 2.2 and 2.4. I guess it would be closer to 2.25. So I'll probably take this one. And we're going to just go up from here. Let's see what the y value is. 3.51. So that's going to be smack in the middle of 3 and 4 here. 3.1, 2, 3, 4, 5. And I'm just going to mark it right there. That's going to be our next point. For the next one, we have x squared is 4, ln y is 4.72. So 4.72. Let's see, so okay, this is 4.9, 4.8, 4.7. I'm just going to mark it there. That should do. And we'll go up here. If x squared is 6.25, ln y is 6.28. Right, so 6.25, just like last question, we're going to take 6.2 here. And we're going to go up to 6.28, see if that's possible. Okay, 6.1, 6.2. 6.3 is a bit better to take here than 6.2 because our number is 6.28. So it's a bit closer to 6.3. That's why I've done that there. And the last point is 9, 8.18. So 9 is way over here on the very edge. And I'm just going to bring this line up all the way to 8.18. Here's 8.1. And it's a bit better to mark 8.2 here, because when you round 8.18, then you get 8.2. So we end up with these 5 lines over here. You want to take your ruler and just draw a straight line connecting these points together. And sometimes you get a really nice line like this where it goes through all of the points. For the previous question, it didn't. So we had to draw a line of best fit, as you can see here. But for this one, if it connects nicely like this, you should try to make sure that your line goes through everything. And as you can see here, we have stretched our line just to make sure that we hit the y-intercept like this. All right, so that we can strike it nicely here. So as long as you have your ruler decently done and your pencil lines aren't super thick, you should have this line roughly at around 2 or so, maybe a bit underneath, but that should be fine. We'll go to the first question. Second question. Use your graph to estimate the values of a and b. Give your answers correct to one significant figure. So what we're going to do is we're going to find the equation of the straight line for this graph. Now, if this is a straight line graph with ln y plotted against x squared, instead of using y equals mx plus c, we are simply going to use ln y in place of y, and then x squared in place of x. So now when we find the value of m and the value of c, we're going to make sure that we use coordinates from this graph specifically. So no more using x and y values. Let's go ahead and find the value of m first. The value of m can be obtained by taking 2 coordinates here. And because the question has mentioned use your graph, you want to try and use points that are not the points that you've already been given. So like these 5 points have already been gifted to us by the question. You want to actually use your line when possible. So we're going to zoom in here, and we're actually going to try and take some points by ourselves. Now this point is the y-intercept. I'm going to guess that that's roughly 0.195, because I see that it's in between 1.9 and 2. So that's the coordinates I'm going to take, and this is from our graph. So that's what they mean when they say use your graph. We're going to use our own here. And I'm going to take the graph, one of the points up here. Really, you can take any one, but I like to take one that's on the line pretty nicely, and that's pretty far apart. You don't want to take 2 points that are super close to each other, because they can make the value really skewed. If you take points that are further apart, you are less likely to get a wrong calculation. I'm going to take this red point up here, and I'll measure it all the way here. This is roughly 7.8. So I know that the y coordinate is 7.8. And if I measure it down, as you can see here, we get, this is 8.2 and this is 8.4. So I have the coordinates 8.4, 7.8, as well as the coordinates 0, 1.95. So when I use the gradient formula, I'm just going to write the points here, 8.4, 7.8, and 0, 1.95. We're going to take the two ln y values and subtract them with each other. So that's 7.8 minus 1.95. And divide them by the two x squared values subtracting with each other. So that's 8.4 minus 0. And you can put this into your calculator just to see what the value is. Over here, I get a 39 over 56. Okay, now we're going to take this and we're going to go to step 2, which is to find c. Now, if you have drawn a graph, oftentimes you don't actually need to do much for this step. So if I update my equation with the value of m that we just found, we get ln y equals to mx squared plus c, where the m value is 39 over 56. Now the c value in a straight line graph is the y-intercept. And if you recall, we did take the y-intercept over here as one of our points. The y-intercept itself, that value of c, is actually this 1.95, just straight up. So we can take that 1.95 and just use it right away. So we're going to update the equation one more time. And we're going to say this is plus 1.95, just like that. And that would be our equation of the straight line. Once you've done this, you're going to try and use this equation to get the values of a and b. Now let's try to recall back on where a and b even are. A and b are located all the way up here in this equation, y equals to ab to the power of x squared. I'm going to screenshot that and put it down here. What we want to do is try to make our equation look like their format and try to compare our numbers with the question's numbers. So in this case, they've made y the subject. We should try to make our equation have y as the subject. This ln is log base e. So if I want to move it to the right hand side, it becomes exponential base e. You can write an e just like this, but just make sure that everything on the right gets pushed up as a power. So you would be looking at something like this. Y is equal to e power 39 over 56x squared plus 1.95. Now, also very similarly to the last question, the format that they've given the answer in is one number multiplied by another. And right now we have just one number on its own with all the powers jammed into one. So we're going to try and split up these two powers using the laws of indices. And you'll see it as something like this. We're going to take this first part of it and times by e power 1.95. If you were to join them back, you would get back this whole term over here, but instead we're going backwards and we're actually splitting them up. Once you see that, notice how they have written the x squared at the back. So I'm going to take this e power 1.95, slot it at the front here, and this is multiplying with e power 39 over 56 x squared. And once you have your equation in this format, then it becomes very easy to compare what the values of a and b should be. So the y here is the same in both equations. Our e power 1.95 would correspond to the question's capital A letter there. The letter b would be our e power 39 over 56. And the power of x squared is just chilling out at the top of there. So in that case, we can then make a comparison and we can say a is equal to e power 1.95. Now, don't leave your answer like this. You always want to check. So let's see. Give your answers correct to one significant figure. We're going to try and do just that. Let me take my calculator, e to the power of 1.95, see what we get. 7.02868. And I'm going to round this to one significant figure, which is just the 7 here. So that's going to be our first answer, our answer for A. And then for B, Now the value of b is the highlight that you see in green. So b should be the same as our e power 39 over 56. Let's see how this one goes. I'm going to round this to a certain number of decimal places, just one significant figure actually. So the full decimal number looks like this. And for one significant figure, that's actually just 2. That's the first figure there. So a is 7 and b is 2. Let's go ahead and check our answers and see if we got it right. I'm going to go to the mark scheme here. So as you can see here, this is the graph, and it's the same values that we had, the x squared table and the ln(y) table. If we look at b, you can see that b is 2 and a is 7. So the exact same values that we have. And in fact, the exact same intercept that we happen to have. ln A is 1.95 and the gradient ln B is supposedly 0.7. I don't think we got a value that nice, but we got something pretty close for sure. So B is equal to 2. That's what we got regardless. That's going to be the answer to question number B. So let's go ahead and do C in just a moment. I'll leave this here in case you'd like to pause the video and take a look. Let's take a look at question C. So for question C, it says use your graph to estimate the value of x when y is 200. Give your answer correct to 2 significant figures. Okay, when they say to use your graph to estimate the value, what you want to do is to make this y equals to 100, y equals to 200, and then check what that value will look like on the graph. Now, right now, remember that our graph is still plotted as ln y against x squared. So if I have y equals to 200, I just need to check, well, what would ln of 200 look like? Ln of 200 is equal to 5.298317367. So what I need to do is I need to check what this ln y value looks like on the graph and what kind of x squared value that returns. So we're going to check and look for 5.29 on the graph itself. Let's go ahead and look for where 5.29 is. So here's 5. 5.29 is basically the same as 5.3, so I'm going to go 5.1, 5.2, and 5.3 right here. And I'm going to try and go to the line and then try to match it downwards to see what x squared value I get. And in this case, it lands us right in on this line. So 4.2, 4.4, 4.6, and that should be an x squared value of 4.8. Do keep in mind that this is x squared, so you have to be a bit careful. The x squared value that gives us, well, that ln y value of 5.3 is 4.8. So we're just going to write that down. The x squared value is 4.8. And if you want the real x value, you are just going to simply take the square root of this as 4.8. Let's go ahead and see what this would be. I'm just going to square root 4.8 here. And we get 2.19. Let's round that to 2 significant figures. So that's going to round here. And that's going to be 2.2. And that should be the final answer. But let us go ahead and check whether that works. We're going to look at the mark scheme. Oops, that's for the first one. Okay, x is equal to 2.2, exactly on the dot. So they allow 2.1 over 2.3, just in case your number is slightly off, but we got 2.2 on the dot, so it should be no problem. So keep in mind that the y value they give, you have to take the ln of it first, and then look for that on the graph itself. Then that will give you the x squared value, after which you should take a square root of that. So that's how you do this question. I'll leave this here. Feel free to pause the video. Let's move on to the final question for today. The relationship between experimental values excuse me, of 2 variables x and y is given by y equals ab power x, where a and b are constants. Number one, transform the relationship y equals to ab power x into straight line form. Now, the way this type of question works is you want to make this equation look like how a y equals to mx plus c straight line graph look like. Now, this y equals to mx plus c only really applies if you have the y and x-axis. So that variable here, y, it can really be something else. The m has to stay as something. The x can change to something else. And the c would have to change to a c. So you just need to have something equals to m times something plus c. And that's what we're going to do. We're going to make our equation try to look and resemble that straight line form. So one of the things that you can do, which is kind of a bit meta, but you can look at the next question to kind of guess what they want you to do. Now, you don't have to do this, but it's a bit ideal because then you'll be able to use the info, translate it into the next question. The next question shows that it's plotted ln y against x. So one of the ideas that we're going to use here is we're actually going to apply the ln to both sides, or the log base of e to both sides. And the reason we want to do that is you can get ln y out of that. Now on the right, you'll get ln of ab power x. And what we want to do, again, is we want to make this look like y equals mx plus c. Mx plus c consists of two different terms. Right now we only have one. So I'm going to try and split up this right side into two different logs. This comes from your laws of logs. So if a is multiplying by b power x, you can go ahead and split that up into ln a plus ln b power x. And if you notice over here, you can take this x down and multiply it by ln b. The reason we want to do that is so that we have something multiplied by x. So just to show you what this looks like here. If I rearrange x ln b to the front, that's going to be ln b multiplied by x. So you can write it like this. And then you can move ln a to the back. Now, why have I done it in this way? The reason I've done it is so that it resembles the something equals to m times something plus c format. Or you can call this capital Y equals to m times capital X plus c. Some of you might have learned it that way. Really, this ln y, this ln y here represents what you should see on the former y-axis. This ln b represents the thing that multiplies by x, or what used to be on your x-axis. So in this case, for us, that's going to be ln b. Our x here is going to be the thing on the x-axis, and the ln a at the end is actually the y-intercept plus c. So that's what I mean when I say you want to make it look like or resemble the straight line form. You want to rearrange it in such a way that you can have this exact lineup of ln y equals ln b times x plus ln a. This would be the thing on the y-axis, this would be the thing on the x-axis, ln b would be the gradient, and ln a would be the y-intercept itself. Once you get here, you're good to go. Now let's take a look at the actual graph itself. This is a bit different because for this question, they've drawn out the graph for us. And this is a line of best fit, so it's by no means perfect, but it's going to be usable. Question 2 simply says, find the equation of the line of best fit and the value correct to one significant figure of A and of B. So the way you find the equation of this line is the exact same way that you do it for all the other questions. You start off with y equals mx plus c, but remember, we're not using y and x anymore. This time we are using ln y, and I guess we're using x down here. So that's going to be ln y equals mx plus c. So we're not using this format, we're using this format for this question. The way you find m and the way you find c is largely the same. So Step 1, let's go ahead and find m. I'll go ahead and use any value I can get from here. And really the two easiest values to use here are going to be the one here at the start, because that's the y-intercept itself. I'm just going to point an arrow to it. That has the coordinates 0, comma, and I think that's a 2.2. And we're going to take one that's a bit further away. Now I look at this top point over here, and this looks like a really nice point because I can get it straight on the line. So that's going to be 4 for the x value. And for the ln y value that it gives, that's going to be 7.8. So I'm going to use these 2 points to calculate the gradient. 4, 7.8, and 0, 2.2. Let's go ahead and use that. I'm just going to write down the points here so I don't forget. M is equal to 7.8 minus 2.2. Your two ln y values, subtract them together, and divide them with your two x values subtracted together, 4 minus 0. I'm just going to calculate this. And that gives me a 1.4. So that's our gradient. And if I go ahead and update the equation, step 2, let's go ahead and find c. The updated equation looks like this. ln y equals to mx plus c, but instead of m, I'll say 1.4. And just like the previous questions, these kind of graph questions in linear law, for c, you can actually just take it directly from the y-intercept. So you don't need to do any substitution here. I suppose you still could, but it's a bit easier to just look at this y value. That's the value of c. It's just 2.2. And you can just plop that in. 1.4x plus 2.2. And ta-da, we have a completed equation. Now what we're going to do is, if I just draw a barrier over here, what we want to do is use this equation to find the value correct to one significant figure of a and of b. Now, if you look at where a and b are located, that's going to be over here. But that's not really a straight line form. You could use this, but you will need to do a bit of changing and manipulation. That's exactly what we've already done in part 1. So we're going to make advantage of that, and we're just going to use our answer from part 1. I'm going to screenshot that so you can take a look at it. If I paste them kind of side by side like this, you can make a direct comparison to what values are equal to what. As you can see here in red, our ln y matches the ln y that's already here. The 1.4 in our equation should be equal to the ln b that you see there. The x's matches up, or they match up. And the 2.2 at the end there would correspond to the ln a right below it. So this is how we make the comparison. And now we can say that 1.4 should be equal to ln b, or if I'm doing this right, I should just say ln b is equal to 1.4. And do remember that you have to solve for b here, so don't leave your answer at 1.4. Move that ln over. This is log base e, so moving it over becomes e power 1.4. And let's see what that is to one significant figure. I get this first, and we're going to round that to 4. That should be our answer. I'm going to go ahead and box that up in green. For the value of a, that's stuck over here. ln a is equal to 2.2. Oops, I'm running out of space. Okay, I'll write it here. ln a is equal to 2.2. And we'll do the same thing here. So capital A is equal to, move ln over, that is e power 2.2. Let's see what this gives us. I get 9.025. I'll just put a dot at the back. And we're just going to round it to the 9 that you see there. And that's basically it. So A is 9 and B is 4. Let's go ahead and check our answer and see if we got it right. Hope I have the right answer this time. Okay. So we have ln y equals to ln a plus x ln b. That was the answer for the first question. So I've gone ahead and rearranged it, but they have even accepted the non-rearranged form, which is perfectly fine. So this answer is acceptable as well. If we go down here, the value of a is 9 and the value of b is 4. They actually have the exact same numbers that we do because you can take the values from the graph directly. Let's go ahead and answer 6.3, or rather part 3, to end off the question. Find the value correct to one significant figure of y when x is 2.7. Ideally here, you want to substitute x equals 2.7 into your equation. There's really many ways of doing this. If you want to, you can use the graph and then just read 2.7. I think actually we'll do that here because it's a really easy solution. So our graph already has 2.7, or rather it already has x being plotted. So we might as well just try to read where 2.7 is, and that should give us a value for ln y. So I'm actually going to try and find 2.7 here for the x value. 1, 2, 3, 4, 5, 6. Okay, here should be 2.7. And so I'm just going to match this up to the graph and see where I land. I end up over here. If I match this to this ln y value, this is 6. Now keep in mind, that's not the value of y, it's the value of ln y. So what I'll do is I'll say when x is 2.7, the value of ln y is equal to 6 directly. And because we have this value, we can just solve for y by moving this ln to the right side. That would be e, and the 6 gets pushed up as a power. And we can calculate this to one significant figure. I get, 403.4287. And you can just round this. So one significant figure should just be 400. Okay. Let's see whether that ends up being the correct answer. I'm going to open the mark scheme. And we get 400. Correct to one significant figure, as you can see here. So that's how you answer this type of linear law question. And of course, when you practice this, do try to practice it on real paper. So if you find worksheets online, go ahead and print them out and have a go at them, because the only way you're going to be able to draw them in the actual exam is if you practice with the real paper. So I know a lot of students these days like to use their iPads to draw them. Try to get a feel for the pencil, because this is one type of question where I actually think it's pretty necessary to do. You won't really know how it feels unless you actually try it out yourself. But that's enough yapping from me. I'll let you take a look at this. Feel free to pause the video, of course. And that is all we have for today. So thank you very much for watching. I will see you soon.